as we know, is nucleophilic addition-elimination. And the reason for dash elimination is in this reaction, a small molecule, the HCl gas, is being eliminated. Basically means lost. So when we do the mechanism, it's better to have colour. I always love using colour because it stands out. Now we know this carbon-oxygen bond is a polar covalent because the oxygen is more electronegative than the carbon, so it has a partial negative charge. So the lone pair, this is our nucleophile, the ethanol, the lone pair attacks the carbon, which has a partial positive charge. This carbon-oxygen bond breaks and the 2 electrons are given there. And remember, a full 2-headed arrow represents the movement of 2 electrons. So each correct arrow scores me 1 mark. So I've already got 2 marks, 1 for that arrow, 1 for that. We then form our intermediate. And normally intermediate, strictly, they should be drawn in square brackets because the intermediate only lasts a fraction of a second. They're very, very unstable species. So we end up with a single bond. You put your lone pair there, there's your negative charge, and you've got your chlorine here, still there, and the ethanol just adds on like that. Nothing too special here. Then with your intermediate, you close the bracket. This oxygen that you can see has 1, 2, 3 bonds. So clearly when it has 3 bonds, it will have a positive charge, a bit like the hydroxyamine that we are used to, which is a protonated water molecule. So this intermediate, you can see the plus and the minus cancel out. It's a neutral species. Now remember, the aim of a mechanism, I always say this, is in maths we say what is the proof of this to this. The mechanism is exactly the same. In chemistry, a mechanism is a way to explain how these 2 reactants, i.e. the ethanol chloride and the ethanol, how do they react to form this ester, ethyl ethanoate, which is a sweet smelling compound, and HCl. And the answer is very simple. You can see this bond reforms, so the 2 electrons go from the lone pair back to there to recreate the CO double bond. This chlorine comes off, so the 2 electrons are given to the chlorine, and this H, if we remove it, we get the ester. You see, there's no H around the oxygen. So that the oxygen needs its lone pair back, and you put an arrow facing the oxygen because the 2 electrons are given back. And that is it. So you've got 3 arrows there, each carrying a mark. So 1, 2, 3, 4, 5, and that's it. Now you can leave it like that, you get your full 5 out of 5, but I would encourage everybody to finish the mechanism off, because when you finish it off, it's just to make sure you don't do that in maths, and in chemistry we shouldn't do it the same. So there we go, guys. I can rub this out here, and that is the full mechanism for the nucleophilic addition-elimination of the reaction between ethanol and ethanol chloride to a way to make the ester.